So welcome to Electronics LA. So in this lecture we will see introduction to digital electronics. Okay. So in this lecture we will see the difference between the analog and digital system. So actually the information can be represented by two ways. Okay. So there is analog and information and there is a digital information. Okay. Any system that works on the analog signals, that is called the analog system, and any signal that works on the digital signal, that is the digital systems. Okay. Then we see that some digital logic labels. So in used in the digital electron, that is the logic 1 and logic 0. Okay. So let us start. So there is two, as I have told you that there are two ways to represent any information. Okay. So electronic system encode the information using the signals. Okay. So these signals actually fall into two broad categories or fundamental categories we can say. So each having the distinct characteristics and the applications. Okay. So one of the representation is the analog representation. Okay. So in this analog in representation, the information is encoded using the uh, continuous value. Okay, so that vary smoothly over the range. Okay, like the hands of an analog clock. So this in this case, the information is encoded as the continuous value. So information actually we have that have the information with the continuous range of values. Okay. So that is the called the analog representation, like the hands of the analog clock. That is keeps us on changing at every instant of time. That is the meaning of analog. So the value we have the value at every instant of time. That is the analog representation. Okay. Similarly, we have the digital representation. So in the digital representation, the information is encoded the finite sequence of discrete values. That is called the digits. Okay. So we are having the information that have encoded into finite set of digits. Okay, that is the finite sets. Basically, we are using 0 and 1 in digital representations, like the numbers on a digital display. Okay, so we have the finite number of these discrete values in digital representation, but in analog representation, what we have? We have the it is continuously varying. Okay, over the range of time or any independent variables. Okay. So there are two ways to represent the information. One of them is the analog information. The second one is the digital representation. Okay. So let us see. You can see analog and versus the digital signals. Okay. So you can see in the left side of this oscilloscope, this signal is your analog signal. You can see this signal is varying at every instant of time. So at every instant of time, if we check at this time axis, at every instant of time we have some value. Okay. So that is our analog signal. So in the right hand side you can see that has the value, but only two sets of values are possible in this case, 1 and 0. Okay. So we have the finite number of values in digital signals. Okay. So let us see. So analog signal, as I have told you, it is a physical quantity that varies continuously with time. Okay. So it can take any value within the given range. Okay. So voltage, temperature, or sound pressure, etc. Okay. So in this case, we can see in this analog signal. So suppose this is the analog signal is represented by sine wave. Okay. So in this case, at every instant of time, you can see if this is the analog signal. Okay, if this is the analog signal, you can see at every instant of time it has some values. If it is analog signal, if every instant of time it has some values. Okay, so this is the T. Okay, so this is the continuously varies with time. The analog signal is continuously varying with time. Okay. So, but in case of digital signal, what we have? Okay. So, digital signal we have, it takes on the only discrete or distinct values. The digital signal, it is a physical quantity that takes only discrete or distinct values. Okay. So, in most digital system, as I have told you, these are the simply two logic levels are there. One is high and low. So, you can see over here also. So, there are two levels are there, either low or it may be high. Okay. So, in digital system, we have two values, or either it may be 0 or high. You can see over here. Okay. So, you can see over here, this is the 0. Okay. This is 1. Okay. So, this is not, these are nothing but the some voltage levels we are denoting at 0, and this is the means high voltage level we are denoting 1, and the lower voltage level we are denoting as 0. Okay, we'll see in details. So anyway, so in this case only we can considering only two values, either high or low. Okay, so in digital systems, that is this is the physical quantity that takes on only the discrete or distinct values. Okay, so this is our digital signal, this is the analog signal. Okay, next one is your, so analog systems, as I have told you, it is process continuous signal. This is the analog signals. It has the physical quantity that vary over the continuous range of time. For example, these are the examples of the analog systems. So traditional radios, analog amplifier, and thermometers. Okay. Next one, digital system. This will process the discrete digital signals. Okay. So it is designed to perform the logic operations in the digital form. So for example, so popularly we have the digital computers, calculators, smartphones. Okay. So these are the examples of digital systems. So what is the advantage and limitation of digital systems? So these are the advantage of digital systems. So it is the easier to design. The digital systems actually are actually easier to design because we have only two voltage levels are there, logic 1 and logic 0. Okay, that is why this type of digital systems are easier to design. Then easy storage, data retained reliably over time. Actually, the storage means the digital system actually we can store that information very easily by the help of some means devices like flip top. One flip top or one latches can hold 1 bit of data. So easy storage. The advantage of digital system is the easy storage. So third one is your high accuracy and precision compared to the analog signal. Okay. Next is your noise resistance. So it is less affected by interference or noise. Okay. So again, we have the high integration. In this case, in the digital system, we can have more circuitry on a single IC chip. So more number of components can be embedded in a single chip. Okay, or it is called the high integration. We are integrating more number of components over a single chip. Okay, so these are the advantage of the digital systems. Okay, but one thing is that we have some limitations also. But what are the limitations? The real world is your analog signal. So like temperature, sound, light, pressure, etc. Okay, so these are the continuous quantities. So to process the real world signals digitally, we do need to have analog to digital conversion. Okay, converter that is required for the additional hardware, adding cost and complexity to the system. Okay, so we must have the analog to digital converter that will convert from analog signal, because we live in the analog world, so that should be converted into digital signal. Okay, and then again the digital signal can be converted into analog signal. Okay, so this is the limitation of the digital systems. Okay, because so we live in the analog world, so what will happen is that, so we have a analog to digital converter, so it will have the analog signal that will be converted into digital signal. Okay, that type of signal. Okay, then this after processing, then we have the digital to analog signal. So back to the real world. This is our analog signal. Okay. So we need to have this type of conversion where when we are dealing with the digital systems. Okay. So next one is your I think logic levels. So what is logic level? Okay. So digital circuits operate using the two defined logic levels. Okay. That each represents at binary digits. You can see what is logic 0. So the lower voltage level in the digital circuit represents a binary digit 0. This will represent a binary digit 0. Okay, the logic low or logic 0. Okay, so in logic 1, the higher voltage level is the digital circuit represents a logic 1. Okay, so these are nothing but the voltage levels only. Okay, the lower voltage level is representing the logic 0, and the higher voltage level is representing the binary digit, that is the 1. Okay, so logic conversion. So we have a two logic conversion are there. So digital circuit follow either positive logic conversion or negative logic conversion. Okay. So we'll see based on these logic levels, we have classified it into the positive level and negative level. Okay. Let us check. So positive level versus negative level. So positive level means the higher voltage level represents a logic 1 and the lower voltage level represents a logic 0. Okay. So in the positive logic convention, what we have? The higher voltage level represents a logic 1 and the lower voltage level represents a logic 0. So logic 1 representing a higher voltage level, logic 0 that is the representing the lower voltage level. So it is taken as a plus 5 volt, that is taken as a logic 1, 0 volt is that is the logic 0. So this is most commonly used convention in digital system. So plus 5 volt is logic 1, 0 volt is logic 0. Okay. Similarly, negative logic, the lower voltage representing the logic 1 and the higher voltage level representing the logic 0. So logic 1, what we have? Minus 5 volt. This is the logic 1 and logic 0 is the 0 volt. This is the highest among these two. Okay. So it is the logic high. So let us see how it is diagrammatically represented. So it is applicable in the inverted signal polarity. Okay. So this is our logic level and logic, negative logic and positive logic. So you can see over here, this 0 volt corresponding to the logic 0 and logic 1 is corresponding to this 5 volt in case of the positive logic. Okay. So I can write over here. So this is our 1 and this is 2, only 2 voltage levels are possible. Logic 1, then set, this is the logic 0. Okay. So we have logic 1 and logic 0. So based on this convention. Okay. So higher of 2 voltage levels, it is 5 volt is taken as 1 and lower is the 0 volt, that is taken as 0. Okay. Similarly, in this case, you can see, and this 0 is taken as the high voltage among these two. Okay. So this is 0 volt. So 0, this is 0, logic 0, and logic 1 is your minus 5 volt. This is 1. Okay. This is 1. Okay. This voltage level is your logic 1. This voltage level is your logic 0. Okay. So this is the positive logic. So in the positive logic, the 5 volt is actually logic 1 and the 5 volt is logic 1 and the 0 volt is that is the logic 0. Similarly, for negative logic, this 0 volt is logic that is 0. Okay. And minus 5 volt is logic 1. Okay. So actually positive logic is most commonly used in the convention on the digital electronics. Okay. So let us summarize this. So we have discussed about the two signal levels. One of the level is analog signal, another one is a digital signal. So analog signals are continuous and digital signals are discrete. Okay. Second one is a two signal types, system types. So analog system that processes the continuous values and the digital system that processes the binary values. Okay, binary digits. So 0, 1 it will process. Okay. Similarly, the digital advantage is that it has the greater accuracy, noise immunity, and ease of storage, but it requires some conversion. That is the analog to digital conversion for real world signals. Okay. Similar logic convention that we have seen that there are two logic. There is positive logic and negative logic. Okay. So positive logic maps high to voltage logic 1, that is the, and negative logic maps low to voltage to 1. Okay. So these are the takeaway from this lecture. So thank you for watching this video. We will meet in the next video. Okay. So thank you all.